Okay, one more time, counting out negative, 1, 2, 3, 4, and then the y is positive. So we're gonna go up, 1, 2, 3, 4. So that's where that point A is going to be. I'm gonna go ahead and write it. 1, 2, 3, 4, 1, 2, 3, 4, and we put our A right there. Now our B, hopefully you're getting the hang of this, is 1, 2, 3, and then negative 2, 1, 2, right there, and that's where our B is going to be.
These are the keys.
And, okay, great. C. Now, C is a little bit interesting because we've got 0 for our first one. That means it doesn't move on the x-axis at all. We're going to go down 1, 2, 3, 4 to right there is C. So that's going to be our C. Okay. Hopefully you're understanding this a little bit of how to plot points. You can see right here in the book, we've got our origin is 0, 0, and then in quadrant 1, that's where the x and the y are both positive. So anytime it's an x and a y both positive, you're going to be in this square right here. If the x is positive and the y is negative, you're going to be down in this square. If they're both negative, they're down in this square. And if the x is negative and the y is positive, it's going to be in this square. So that helps you know what area it's going to be in, and then it's a matter of counting out. I will say sometimes the space between the lines is not just 1. So if you're plotting something like number of elephants and how many pounds they weigh, well, you can't do 1 pound each one, so you're gonna have to have it be thousands of pounds or something like that. So it doesn't always correlate 1 to 1. In this one, for practice, we're gonna go ahead and just start with 1 to 1. Okay, our next question is going to basically say, give us a function, and then it's gonna ask if we can graph that function on graph paper. So my function is x equals 2x minus 1. So how do we graph that on paper? We're going to start by going ahead and getting just some points that we put on there. So if x is negative 2, when we take this, we plug it right in there. 2 times negative 2 minus 1 equals negative 5. So y equals negative 5 if x is negative 2. Let's go ahead and try it with a few other numbers so we can get a few numbers that we can go ahead and plot on my graph. So if x is negative 1, negative 1 times 2 is negative 2, minus 1 is negative 3. If x is 0, now we've got 2 times 0 is 0, minus 1, y is negative 1. If x is 1, 2 times 1 is 2, minus 1 is 1, y is 1. If x is 2, 2 times 2 is 4, minus 1, y is 3. So I'll go ahead and write out my points then. At that point would be something like negative 2, negative 5, negative 1, negative 3, 0, negative 1, 1, 1, and my last one is going to be 2, 3. Okay, now these we're just going to put as dots just like we did up there. So negative 2, negative 1, 2, 3, 4, 5, kind of running into my space down here. Negative 2, negative 5, negative 1, negative 3, 0, negative 1, 1, 1, and 1, 2, 1, 2, 3 right there. You might be able to see from this, it actually is a straight line. So your next one, if they were to ask you what would the next dot be, well, you wouldn't even have to plug in 3 into your equation over here, though you could. If you plugged in 3, it would be 2 times 3 is 6, minus 1 is 5. But the other thing you could do is just look at the graph and see the pattern. And 3, it would be right up there because it looks like it's going over 1 and up 2. Over 1 and up 2, over 1 and up 2. So you could, looking at the graph, figure out the different points from there. Okay, that was a little bonus for you, because I think you're going to get to that in the next couple of sections. All right, this last one is saying we've got some data. It's talking about when women were allowed to vote in the election, how many millions of votes we had in the United States every year. So this is the presidential election, so it happens every 4 years. And in 1920 was the first year that women were allowed to vote. And so we're going to make that 0 because that's going to be our first, or that's going to be we're looking at before and after women were allowed to vote. So we've got 0, -4, that's going to be 1916 and 1912, 1908. But we're going to put them as 0, -4, -8, and 12, and 4, 8, 12, because we want to see what it looked like before and after women voted. So here's our numbers for before and after women voted. And it says, explain how you know that the table represents a function. So the table represents a function because each input has exactly one output. So every time we talk about how many it is for 1 year, then it tells how many people voted. So we have a 1-to-1 correlation there. We don't have more people voted. We don't have more years. So that's how we know this is a function. I don't quite understand all of that, but I think they're just trying to help you understand this lingo of tables and functions and what they are. So we're going to go ahead and graph that out. And here I have my X and my Y. Notice I brought my X all the way down here because I don't have 0 people voting or negative people voting. So I'm not going to have anything down in these 2 quadrants. Everything's going to be up in these 2 quadrants because this is representing how many people voted and this is representing the years. So I do have negative years because it's all based off of 1920 being my 0 point. And then because I did this one as 4, I'm going to go ahead and just do that one as 4 because it works without it being too spaced out. You could have done that as a function of, you could have had each space be 5 or 10, but I went ahead and 4 worked, and then they can both be the same. They don't always have to be the same, but that's what we're doing for this graph. So if I look at my points again, I might start with this one right in the middle, 0 and 27. So I look over here and 0 on my X, and then I'm going to go up here to 27 is right there. And then the next one, if I want to move to the right, I have 4 and 29. So I was just doing 4, 8, 12, 16, 20, 24, 27, 28, 29 right there. And then after that, I've got 37 and 40. So this is 32, 36, 37, and that one is 40 right there. So it's going to be right on the line. Then going backwards, I've got in the year 1916, there was 19. So again, 4, 8, 12, 16, 19 right there. And then 15 and 15. So -8 and -12 are both 15 and 15. So it's not a perfect line because usually you don't have a perfect line when you're talking about real world data like that. But you can tell the trend based off of these points. And the trend is more and more votes are being cast after women were allowed to vote. Kind of makes sense logically, but also you can just see on this graph, it's just kind of giving you a picture of what happened. So that helps us kind of see data in a real world way. says describing trends. I just said that continues to increase after women were allowed and the years after that. That's really it for examples. The only other thing I was going to touch on was talking about functions. These are functions. So when they say graph the function, there's a function. You could also say equation, but it's anytime you've got two variables, you're going to graph that out. That's called a function. Graph the function y equals 2x minus 1. And you're going to have one, for every value of x, you're going to have one value of y, and vice versa. You're not going to have two different values for y. Eventually you will, and that's when you're talking about exponents and things like that. But for right now, it's just a single y and a single x, and that is going to go ahead and every time you have, if you plug in a number for the x, you're only going to have one value for the y. Or if you plug in a value for the y, you would figure out the one value for x. It doesn't have an option to be anything other than one value. All right, that is 4.1.